crystalline solids have sharp and characteristic melting point. So you will get an accurate value for the melting point of crystalline solids. But in case of amorphous solid, you will not get an accurate value. You will get an order of value. Let's say for certain crystal, the melting point is going to be 100 degrees Celsius to 104 degrees Celsius. So that is the order of that is the range of 4 degrees Celsius. So range of temperature you will get as a melting point for amorphous solids. But for crystalline solids, you are going to get an accurate melting point 100 degrees Celsius, so you will get 100 degrees Celsius. So that's the point. Crystalline solids have sharp melting point and amorphous solids do not have sharp melting point. You will get a range of temperature as a melting point. Crystalline solids have definite enthalpy of fusion and amorphous solids have indefinite enthalpy of fusion. Enthalpy of fusion, we study it in the chemical thermodynamics. When we have to fuse or when we have to convert 1 mole of solid into liquid state, that is called as a fusion process, and the energy change related with that fusion process is called as enthalpy of fusion. See, the enthalpy of fusion is different thing. The energy associated with converting 1 mole of solid into liquid, and that happens at a certain temperature. That temperature is known as melting point. So you should understand the difference between melting point and enthalpy of fusion. So crystalline solids have definite enthalpy of fusion and amorphous solids do not have definite enthalpy of fusion. When we will cut the crystalline solids, you will get a plain and smooth surfaces. Suppose I have the such type of solid with such structure, and if I put a cut over here, we will get a plane, a smooth plane I am going to get. This is smooth plane that I will get when I will cut the crystalline solids. But in case of amorphous solids, you are not going to get the plane surfaces, you will get the irregular surface. That is another property depending on the arrangement of particles, that is regular or irregular. These are the another properties. The first one we are seeing over here is very important, anisotropic and isotropic. Crystalline solids are anisotropic, whereas amorphous solids are isotropy. Now let's understand what is mean by anisotropy and isotropy. So in case of anisotropy, we can see, yes, these are the constituent particles of solid, brown ones and blue ones, different particles of solid arranged in a manner. So we can see the definite arrangement of particles. So obviously this is crystalline one. This is crystalline solids as its particles are arranged in a definite pattern. Now if we study, if we observe different properties like electrical resistance, refractive index through the different direction of crystalline solid, let's see the direction. This is one of the direction, okay, going upward. We can see that in that path, in that direction, we are only having blue particles, correct? In another direction, we can see we are going to have both the particles, the brown ones and blue ones also. So if the particles present in the given directions are different, that property is also going to be different. So in crystalline solids, through different direction, we get different values for the same property. Let's say for refractive index, through the blue particles, we will get different value. Through the brown and blue ones, through the cross direction, we will get the different value for refractive index. Therefore, crystalline solids are anisotropic solids. Whereas in case of amorphous solids, you observe, you determine value of property through any direction, you will get the same value. Therefore, they are called as isotropic. Iso means same, aniso means not same. So in case of crystalline solids, properties are not same through different directions, but in case of amorphous solids, properties are same in every direction. So that's the case in case of crystalline and amorphous solid. So let's see what are the other properties. Crystalline solids are called as true solids, but amorphous solids are not true solids, therefore they are called as pseudo solids, or they are also called as supercooled liquids. I explained you in the case of crystalline glass and amorphous glass quartz. When we heated crystalline quartz, we got the amorphous one. It means that when crystalline solid is heated and fused and cooled rapidly, then we are going to get the amorphous solid. Therefore, it is called as super cooled liquid or the pseudo solid. Examples are given over there. Copper is a crystalline solid, silver, iron, sodium chloride, zinc sulfide, potassium nitrate, crystalline quartz. These are the examples of crystalline solids, and we can have the many more examples in crystalline solids. In case of amorphous solid, glass, rubber, plastic, and just now we have seen the quartz glass. These all are going to be amorphous solids.